So this question here focuses on graph transformations and the effect all the various movements have and how they look for the graphs. Now, when we do a question like this, there's a few things we have to remember. Firstly, we have to remember the general way everything changes. So if we remember y equals a f of bx plus c plus d, that a, b, c and d all has a different effect on the graph in different manners. So for example, a changes the magnitude of the graph. Remember we talked about this, and that's a stretch or a squash up and down. The b has an effect in terms of the magnitude going along the x direction, so a stretch or a squash there. That plus c has a direct effect on the x, but it's adding something, or it could subtract something to it, so it's going to move it left or right. And that plus d moves the graph up or down because we're adding something on, having an effect in the y direction. So when it comes to a question like this, what we have to do is remember what each of these effects are and determine which effects are present in the graph that we're after, and then do them. Now, another key thing as well, we have to remember that any points marked on the original graph must be shown on the new graph so that we can show and indicate how they have changed. It doesn't matter about any other points. We don't have to plot lots of different points along the graph or anything like that. We're not given the specifics of the function, but we have to show these key points. This is vital because it shows and indicates that we understand and we know exactly what's happened to it. So we have our original graph here. And what it's saying is, on the diagram in your answer booklet, which I've copied here to the right, sketch the graph of y equals 2f of negative x. So what we have to do is determine the effects of those two parts. So one of the effects is the 2 times the f of negative x, and the other one is the negative x part itself. Now if we look at each of them, we know that the 2, what that's going to do is multiply, so that's going to change the height and the magnitude of the curve, and it's going to have an effect on each of them. Now, this point here at -1 and this coordinate here at 2, they're both on a y value of 0, so their magnitude isn't going to change. Anything times 0 is still going to be 0, so they're actually going to remain where they are on the x-axis. The big one that changes is this one here, the -2, because what's going to happen is that's going to multiply by 2, and it's going to go down to -4. So that coordinate there is going to go down and become this coordinate here, down on the -4. If we look at the other effect, the negative x, what that does is that takes our curve and flips it and reflects it in the y-axis. So every point on the right switches across to the left, every point on the left switches across to the right. So the point that's at 2 on the x-axis, as we reflect it in the y-axis, that moves to here, and -2 now on the x-axis. The point that's at -1 currently reflects again in the y-axis, and it moves to here, to where 1 is. Now we've looked at where each of these points move. The general shape of the curve doesn't change. It's still going to have the same overall shape. All that's changed is the location of these points. So when we sketch it, we just have to make it look like it did before. Which is right there. So that there's a pretty good sketch of it. Name it as well, just for completeness. So we know that that's y equals 2f of -x. And that's us done it there. That's us completed the question because we've shown how each of these effects take it, and we've indicated it by putting on the points. Where have the original points now moved to on this new graph that we've drawn? How has it had an effect on them? And what has it done to them? Now for this question here, it's worth 2 marks. 1 mark is to show how the effect in the x-axis occurs in the new diagram, i.e. that it reflects in the y-axis. And the other mark is for showing how the amplitude or the magnitude of the curve has changed, i.e. that -2 has gone down to -4. So you get a point for showing each of those 2 effects on the graph. Now when it comes to it, the biggest thing you have to remember is how the A, the B, the C and the D all affect the curve overall. if you can remember how each of these effects occur, what it does to the function, and show how it modifies the important points from the original graph, you should manage a question like this, no bother. If you remember those, it'll be easy peasy, lemon squeezy.